Okay, hello. This video continues on with the wing. If you haven't seen my first two videos discussing the wing, then you should probably view those already. Okay, but now what we're going to talk about is we're going to talk about some more phraseology and verbology associated with the wing. But this is actually the top part, or the span, or the top view of the wing. So let's go ahead and draw that. So let's say I had an aircraft right here, and this is the empennage going to the body, the fuselage, and then the top part. So this would be your front, and this would be your back view. And don't worry about if you don't know what I just said on that phraseology. I'll make more videos about it. But we're going to draw the wing. Now I'll use a different color right here. So your wing is going to come out like this, go up, and like that. And since this is the left wing, it would be an aviation red. All right. Okay. So basically, here's how it works. Actually, that would be aviation green. Okay. Man, God. See, this is what they call the golden shovel rule in CFI. You just don't start opening your mouth and talking about stuff. Okay, so that would be aviation green. Okay, so this is your wing right here. Now, when you're looking down on top of the video, or top of the video, wow, I need breakfast. Okay, when you're looking down on top of the wing, basically the two lines are the two terms right here. You got more lines, imaginary lines. What you do is you have your wing chord, which is, of course, your leading edge right here, which goes to your trailing edge right there. So you got your leading edge going to your trailing edge. At this point right here, this is known as your wing root. This is your wing tip, WT, wing tip. And this is as skinny as the pins go, so I can't really get any skinnier than this. So that's your leading edge. Hang on, that's okay. That's your leading edge. That's your trailing edge. That's your wing root. That's your wing tip. Okay, and then you can draw another line right here. Now, of course, for mathematical purposes or for purposes of deciding the other engineering related stuff, you're also going to have a line that cuts the airfoil section in half. However, this gets pretty complex because in this example, I use a perfectly rectangle wing, but then when you start talking about delta wings and everything else, this little line right there can get very complex. But okay, for the concept of this though, we're going to use a rectangled wing. Now, of course, this is when you start talking about your aspect ratio. And if you remember from your lift equation, aspect ratio plays a significant factor in determining your lifting effect of the wing. Basically, your aspect ratio is the measure, or the mathematical measure, of your total lifting surface of the wing. And for a perfectly rectangle wing, in this case, it would be your wingspan divided by your wing chord. Okay, because that would make sense. I mean, if you're talking a perfectly rectangle wing right here, then if you wanted to figure out how much wingspan you actually had, it would just be a matter of measuring your length over your width, or your length over your width, and then that would give you your total area, your total lifting surface, if you will. The problem with a lot of wings, though, is that they're not completely rectangle. They're delta, or they have some type of let me see, what is the word I'm looking for? They have some type of curvature into the wing root, or the leading edge, which causes it to change up a little bit. So this formula is actually going to change. And what I'll do is in the next video, I'll go ahead and explain how you would measure aspect ratio for a wing other than being a complete rectangle.